Hi there. This is Ross Dahlke. My opinion was predicting opinion change in deliberative groups. My project deals with a deliberative democracy. Deliberative democracy is when you poll a group of people about policy issues. You then bring them together for a week of expert talks and, most importantly, a weekend of deliberation where they break up into small groups and they talk about the issues amongst themselves. And then, after the weekend is over, you poll them again and you can see how much their opinion changes just from talking about those issues in a group. This method was really uh, predominantly done by Stanford professor Jim Fishkin in the Stanford Center for Deliberative Democracy, and I'm thankful that they were willing to share their data with me for this project. And so the data that they shared with me was surveys of individuals that participated in these deliberative democracy polls. They, the surveys were people's opinions before and after, and so I was able to calculate the difference, the delta in opinion. And then they also gave me the transcripts of the groups that those people were in. And so my task was I was trying to predict the amount of opinion change within a group based on the transcripts. And so here is an example of a chunk of one of the transcripts. And in this one, a woman in Uganda is talking about how she believes farmers should market their produce and some of the government help that she believes that farmers should get. So like I said, I try to use the contents of these transcripts to try to train a deep learning model to predict how much that group's opinion would change over the course of the pre and post surveys. And so for this, I relied primarily on word embeddings. And so I broke the transcripts up into 1/10 chunks, and then I ran a couple models. So this first one here that says one word embeddings, that is just comparing the first and the last word embedding, the similarity, the distance between them, and then just throwing that into a linear regression and trying to predict the group's opinion change from that. The all word embeddings you also used a linear model and put in all the combinations of those 1/10 chunks into the model. And then I also train a basic neural network with all of those chunks. And as you can see here, I use two different embedding models. I use both the Spacey core model as well as the BERT model. The most the model with the minimized loss is the basic neural network with the Spacey embeddings with a mean squared error of 0.064. You can also see here that I also trained an LSTM as well as a BERT transformer, but they were not as accurate. So when I say a basic neural network, very basic, here's the architecture, just a couple of layers. And it was that basic because I ran into one big problem. And that was almost any of the models that I used, the predictions that would come out, they would be almost exactly one number. All these models, when they tried to minimize the loss, would just find the number, the single number that would minimize across all of the training examples. And so even though the mean squared error was pretty good, it ultimately isn't that useful for making inferences. And so my next steps would be to try to do more feature engineering to get linguistic features like polarity or subjectivity or incivility that I could put into a model instead of relying on a black box approach. Thank you.